process of crushing is, the traditional way of doing it is you quarry the stones in the quarry, and then you bring it down to a size in the quarry itself to about 400 to 500 mm diameter. So those are called boulders. These boulders are transported to the crusher, and the first stage is what is called the primary stage. Most of the companies or other crushers use jaw crushing system.
Okay.
Jaw is basically, it's like teeth coming from both the sides, and then crush the stones, bring it down to small pieces.
Okay.
Generally, when it is crushed, it comes to 100 to 150 mm size. 500 mm size comes down to small size.
And it's reasonably uniform.
Reasonably, I would say. It's not uniform, but it's reasonably uniform. Because this is not a controlled crushing.
Absolutely.
Okay. Then, I'm talking about the traditional methodology.
Right.
This stone again goes into another jaw crusher, and then again gets crushed into smaller pieces. Again, there is no consistency in crushing. When it gets crushed, then what they do is they put it into screens, various size screens. Screens could be, depending on whatever is the market demand, 20 mm and 12 mm are the largest selling material. And there are certain requirements like road requirements where they require 40 mm sizes, sometimes 60 mm sizes for certain requirements. But mostly the majority is 20 and 12 mm size. So when this is crushed and then it is screened, find that there are certain material which falls into the 20 mm category. So it goes into a conveyor and then falls into the stockyard. But certain material which is lower in size goes into the 12 mm stockyard. During this crushing, there's a lot of dust generated. This dust is collected separately, and it is actually in the earlier period it was actually it was waste dust, right? Because as it is in this system of jaw crushing, the size and shape of the material is absolutely absurd. There is one might have a different shape, the other one will have a different shape. One will be elongated, the other will be rounded, the other will be. So, but that was the system, because the system they were adopting was this jaw crushing. 99% of Indian crushing industry uses this methodology.
Traditional methodology.
Okay. These are normally small plants which can generate rather crush about 200, 300 tons, 400.
People are still actually, it's large units and big money, right?
Yes. And again, see, this is one industry where, of course, there is a pollution control board, there are other controls, but then generally, it is run by people, a lot of illegal
Politicians.
Yeah,
I can imagine.
a lot of illegal kind of operations happening. Yeah. It's been going on for years together and controlled by these kind of people.
Right.
Now, some corporates have got into this business. One of the first corporates to get into this business was a company called Silica.
Okay.
Hyderabad-based company.
Silica.
Yeah. They've done a good job. First thing is they have embraced the new technology. Rather, this technology was available, but not many people used to, except a few companies used to use. Not saying that it is only used by Silica the first time. No companies using it. This is basically a 3-stage crushing.
Just in terms of the traditional method, so some of the issues there were, it was not very consistent crushing, the quality of crushing was not high quality.
Yes.
Energy inefficient, I would imagine.
Yes.
Okay.
And very high generation of dust.
Dust, okay, which was waste essentially.
Which was waste.
Okay.
Which was waste. This was is a particular.
Yeah, I understand that because I know where it's going. So.
Yeah. Now the technology which is including ours is using a 3-stage crushing technology. So the first stage is jaw crushing itself. So you get this large boulders, bring it down to smaller sizes. From the next size is about 150 mm size. Then it goes into a cone crusher. Now, what we mean by cone crusher is that the design of the crusher is such that the stones, when it goes into the crusher, it is when it breaks, it is broken into a conical shape. Okay, the stone. So it's got a sleeve, and in between it goes in, and so the whole, when it crushes more or less like a cone. So the idea is that the shape of the aggregate itself is it should be conical, okay, or rounded, cubical.
Similar sort of conical shape, yeah.
And then after this cone crushing, it goes into something called the VSI, which is known as vertical shaft impactor. There, what happens is the stones are crushed into smaller sizes, again uniform size shapes, size and shape, and then it is then, so there are 3 stages now: jaw crushing, cone crushing, and then VSI crushing. Right? From there, it's screened, and then you take out whatever material you want. Now, in this VSI, you find that the material which comes out is of uniform size, uniform shape, plus you get sand-sized material, okay, which is below, say, 4.76 mm. Sand is supposed to be 4.76 mm maximum size aggregate. Below that, is generally can be called as sand-sized material, which has got more or less uniform size and shape. Important thing is shape and size. Okay. Now this is again screened, so below 4.6 goes into the sand stockyard, and 12 mm, 4.76.
Below 4.76
is sand.
Classified as sand aggregate.
So now you would ask me, what is the difference between this sand, because it's also a byproduct of crushing,
right,
compared to the dust which I was talking about. Now dust, as I said, is not controlled. It comes out as a very fine powder with, if you look at it microscopically, you will find that the shape is elongated, more elongated, more fines. So what happens is, this actually is not supposed to be used for concrete because of the size and shape. Right? It consumes more water. So the water cement ratio, if you understand concrete, one of the critical aspects is to reduce water in concrete. Okay. Reduce water, increase your strength, increase your durability of concrete. But this acts the other way now. It consumes more water.
Soaks in water.
Soaks in water. Because it's very simple, you don't need a technical this about it. The shape is, when it is elongated, that means it has larger surface area. So you require extra water and extra
additional wetting is required into the requirement. So it
requires some water, otherwise there is no workability. Now, whereas in the manufacturing side, you find more smaller cubical size.
Of this.
Now it's not a byproduct. Now
which itself is useful.
No, it is not a byproduct. It is manufactured to that extent. Now, for example,
so it's intentionally manufactured.
Yes. Now, many times I don't manufacture the large stones at all. Okay. I manufacture only sand.
Okay.
So it's not a byproduct. It is manufactured purposely. It has been designed in such a way that I can decide what percentage I want. I want a 70% sand to come out of my VSI, 30% the rest of the material. Right now I'm manufacturing about 65 to 70% of sand alone. So it's designed that way. So the VSI is such a thing that you can change your settings to give you the different sizes, shapes to some extent, and then increase your quantity of sand particles.
Okay. So when it comes to, so then if you compare traditional sand and this manufactured sand, in terms of its structural properties, in terms of its water absorption and so on, it is at the same level or better in terms of performance.
It's different, certainly different, dust. Okay. You asked me about the structural differences. See, river sand, how is it formed? It's formed over centuries of water falling over rocks, basically.
Right.
And so the water is what, the pressure of the water is what gives it the size and shape, because the movement of water, the size and shape. And so when it is cut, it's cut into smaller pieces, to gravel pieces, then again it's cut into smaller, that's how it happens, right? And it becomes the sand size. So the shape and size of this sand, and then again it is always in water, so it's always, absorbed in water, so it's naturally
Saturated,
yeah, saturated in water.
Yeah.
So it has got lesser saturation as it is.
Fair enough. It's a fair point, yeah.
So there is, when you take out sand and use it, your requirement actually, requirement of water in concrete comes down, because it's already saturated with
Moist,
unless it is completely dried out. Normally people don't wait for that kind of period. Always there is about 2% to 8% moisture in sand.
Right.
Whereas in this dust, normally, I mean, dust, there is no moisture at all. It's completely dry. In manufactured sand, also, the moisture content is almost similar to your dust. There's hardly anything. But what we have is a slightly different system.
Okay.
We have the fourth stage. Apart from this VSI, we have the fourth stage where we put this sand through a washing process. Okay, there is a washing machine. Okay, to put it in simpler terms. And there, the whole the sand is fed into this machine, and water is fed in. And then, what happens is this pulls the finer particles and removes the finer particles. The finer particles are pumped into a tank, separate tank.
Okay.
And then we only take out the washed part of it, that is the coarser part of that, and use it as sand. Okay.
I see. So the centrifugal forces of the rotation,
Yes.
you separate them out,
Separate
almost
them.
like fractional distillation. This takes it out.
Exactly.
Okay, got it.
Now, in normal crushing, what happens is the finer particles are anywhere between 15% to 25%. The fines, which is below, say, 300 microns, 600 microns. I would say that below 300 microns is about 20 to 25%. That's now finer the particles. The issue here is that it is got larger absorption of water. So your water requirement goes.
Correct.
So ideal thing would be to remove this fines. Natural sand doesn't have this kind of fines, except when it has got a lot of silt.
Right.
So the idea of this fourth stage is to remove this fine particles.
Okay.
Not many people do that in the country. We do it. Again, we are not making 100% wash sand. What we are doing is that not many customers want this wash sand. First thing is there is moisture inside. So many people don't want moisture. It's stupidity, but that's what people.
Okay. So they ask you right after the third step, after the BSI itself, they ask you for the sand. They don't ask you for it to go through the.
Yes.
Okay.
But what we do is we still manage to, because we want our fines to be reduced. So what we do is we mix a little bit of these two materials. The wet sand, the wash sand, and the dry sand. We mix it so that the fines come down dramatically. There are some people who insist on only on dry sand, and we supply because it's all market driven.
Yeah, sure.
So we give it to them. But most of the people who don't insist on 100% dry sand, what we do is we mix it with this. There are some people who insist on completely wash sand.
Okay.
We give them wash sand.
Okay. And the water usage there is it a significant amount of water usage with washing?
Yeah, approximately about it works out to after recycling. This water is recycled.
Okay.
So what happens is this washed material goes into a tank, it settles down, and then the particles, the sand particles are removed, and then the water is filtered and sent back to the machine.
Same thing. Okay.
So we consume about 160 liters to 200 liters per ton of water sand. So it's yes, there is a consumption of water there, but it's better to give the customer what they want. If somebody wants a good sand, we give it to that extent. What I'm talking about 160 is when 100% What
Of
sand
it is
used.
it's the moist sand.
But we, as I said, we right now manufacture about 50% dry sand. So water consumption will be lesser to the same extent.
that, yes. Fair enough.
Okay. So this is what we do as a as a responsible organization to give the customer whatever is the best possible in terms of quality. Most of the other people, 99% of the people do not have this washing systems.
Okay.
I would say apart from Kerala there is a lot of quality consciousness. They use only washed sand.
Okay.
Yeah. But they may not have the centrifugal system, they might have different systems, but they wash the sand.
Okay.
So this is the, I would say, is the system involved. So structurally, if you speak about it, in our sand, in what happens is once we remove the fines to a very large extent, the water demand actually is still higher than the natural sand,
The conventional
but
sand.
much lower than the crushed dust.
Okay.
The dust what we're talking about. Number two, as I said, structurally the size and shape is uniform, so it's far superior to crushed dust. In terms of similarity with natural sand, it's very closer to natural sand, but it is certainly not the same as natural sand. Number three, advantage over natural sand is there is no silt content.
Okay.
Natural sand can, nowadays when they are mining from the bottom of the river, a lot of silt comes in. Here, zero silt. It's clean sand.
Okay.
And it's much more environment friendly. I'm not saying this is 100% environment friendly because we are again breaking the rocks. But compared to the river systems,
It's
yeah, this is any time superior. So environmentally friendly, in terms of environmental friendliness, this is much superior than river sand. In terms of performance in concrete, it's superior to river sand because it gives you a higher strength.
Fair enough.
And pricing, it's still cheaper than river sand as of now.
It's cheaper.
Cheaper than river sand.
How?
We have no choice here to price it cheaper. River sand.
Oh, because of the acceptance, you need to sort of still,
See,
capture a fair share of the market
No,
before you can.
that's not the only reason. River sand still is regarded
Okay.
by consumers as the superior product. It's always regarded as that.
But they're used to it.
Yes. And the supply of river sand is controlled now. So the demand supply mismatch, gives the river sand a price which is, say, right now it is going at say 40 rupees or 50 rupees per. 35 rupees to 40 rupees here, I think, is the price for river sand. So I'm forced to position my brand or product slightly lower than that, say 5 rupees lesser than that. But it was earlier when it was introduced, most of the people sold it as a byproduct, a crusher dust kind of stuff.
Okay.
So they were pricing it at a very low price. But we have educated the customer that this is, and we have this washing system, so we priced it better than that, and we got a reasonable price from the customers now. People are prepared to pay slightly more for our products compared to other.
Because they're understanding the benefits and so on.
So there's been a lot of conversion from river sand to this one, but many of the people unfortunately still use crusher dust. So earlier when it was a waste, now it has become a very useful product for construction.
So, and why is that? Because it can just be obtained much cheaper.
It is cheaper.
Okay.
Because it was a waste. Today, whatever price you get is recovered if you're, some money you recover.
Additional income.
Additional income. So now what has happened is because of the tremendous shortage of sand in the market, they have increased the prices of dust. They keep a difference of say 10 rupees per CFT between our material and their material. And they pass it off as sand itself. There are people to buy it. Now even some of the RMC companies, some of the RMC companies,
They mix it.
they mix it because economically they find it naturally when one sand is 10 rupees cheaper.
Yeah, we've heard about it as well. So it's not surprising.
So it's not.
But I'm sure RMC guys are actually saying that this is far superior to, and then they're also.
It's not a right thing to do because naturally when fines are more, crackability is higher. You consume more I mean, naturally you have to consume more cement because as a mortar you have to cover the surface.
Right.
More cement. More the cement, concrete is not good. People have a belief that you add more cement, it is good for
Gets stronger. Yeah.
Certainly no. Yeah, it is stronger. But strength is not the only criteria. The important criteria is durability. People in India have completely forgotten the concept of durability of concrete. So people only look at strength.
Well, that's what is advertised, no? Gujarat and Gujarat cement is for strength. So
No, that's okay. Cement can say that why cement is strong. But ultimately, cement is used in concrete. So concrete has to be durable, for which your concrete has to be designed that way. So we are contributing to some extent to improving durability compared to what the crusher does or whatever they're using. We are contributing to an eco-friendly product because it can reduce the usage of natural sand.
Right.
And we are right now economical.
So economically it's viable.
Certainly it's viable.
Okay.
For a company to start producing this, you require, higher capex. So a lot of these small fellows cannot bring in the kind of capex. That's where the issue is. That's why many corporates will have to come into this kind of business. But they are not coming in because there are a lot of local issues. Wherever you put up plants, the localites come in, create issues because there is mining involved, quarrying involved. Crushing is always regarded as a dirty business. It's always been done by such people. But now things are changing with a safer zone which is coming now. The government has insisted that it has to be put up in certain areas only so that you can control the pollution, emissions and such things.
Right.
But I would say that, in my opinion, rather than doing that, best thing to do is have stricter pollution control norms, like country like Singapore, where it's such a small country. There are crushers inside the city. How are they managing pollution? Same norms should be applied. Let it be wherever it is, as long as it doesn't pollute the environment. There are methods to control it. Why not?
How's the acceptance been of the product, both on the sort of the individual consumer side as well as on the business side?
The acceptance is high amongst ready-mix concrete manufacturers.
Okay.
Concrete mechanized concrete manufacturers. Acceptance high. Amongst individual customers, they still have a mindset that this is duplicate sand, right? This is a fake sand.
Fake sand. Okay.
So they would prefer to use natural sand wherever possible. But there are areas like, as I said, regions like Kerala and now Andhra Pradesh, where natural sand is not available. They have no choice. They have to use this
Partly shift to this.
They have to shift. That shift will take place. It is good for the country as a whole because the river system will not be exploited. If governments like what you have seen here, if they insist on manufactured sand, here again they are not banned river sand, but government themselves are promoting manufactured sand.
Yeah.
But issue here is again, a lot of people will have to come and invest in such plants. This is going to cost anywhere between 8 to 15 crores of an investment if you want a decent plant.
So the 4-stage process.
Even if the fourth stage is not there, 3-stage itself.
I think the typical job crushing would be about 2 to 3 crores for a fairly decent size.
Yeah, you can even put it up with 1.5 crores. 1 crore, 50 lakhs, 60 lakhs, there are plants. Local fellows can manufacture. So there are such plants. So if you have 50 lakhs, you can put up a plant and run this industry. You make a lot of money. See, the difference here is, even for the government, the difference here is if they encourage corporate sector or other companies to invest. One thing is that corporate sector does not cheat on taxes, cheat on royalties.
More organized.
Much more organized.
That's the thing.
Whereas the income for the government from these royalties and taxes today, I can say that, I'm not blaming, I would say, my rough guess is that they may be earning only 50% of the actuals. So whereas we pay 100% royalty, 100% tax because we are an organization.
Right.
We cannot avoid all this. So these are things which, if they help these or consolidate the smaller players to, or make them sell it to larger companies. like what has happened in civil industry. It was all a lot of small companies. Now, a lot of larger companies have come and see.